set, interval notation, unions, and intersections. Set is a collection of object or elements. Roster form is a way to use set notation, and you're going to use it in braces with braces, and you're going to put commas in between. We've talked about this before, roster notation, set notation. So here's an example. The set of prime numbers less than 10 expressed in roster form. Well, you've got braces and you also have commas. We've talked about how prime number is any number that's greater than 1, that is exactly 2 factors 1 in itself. So 1 can't be a prime number, 2 is, 3 is, 4 is not, 5 is, 6 is not, 7 is, 8 is not, 9 is not, and then less than 10 you're done. Set builder notation. It's a notation used to describe the elements of a set. So here's an example. We're wanting to write the set of all positive real numbers using set builder notation. So we're looking to do this, the set of all positive real numbers in set builder notation. The way that it looks like it's this whole thing, the braces, the X, the 2 points, the colon, the X, that weird E, the weird letter R, and X is greater than 0. Here's how you read this. The set of all X values. So the set of all X values, this word, the set of all values of X. Here we go. And this is the set of all values of X. When you get to the word such that happens to be the colon. And then X is a real number. I'm going to go, here I got blue. So such that X is a real number. That's this thing right here. X is an element of the real numbers. The word ands go on both of those, right? So and is here, and is here. And then X being greater than 0, you know that notation already. X is greater than 0, X is greater than 0. And then you've got the ending of the braces. So just be familiar with how to read this or how to write it. You'll see it more in the multiple choice questions, and we'll get to an example of that in a second. But if you wanted to do this next bullet, express the set of ... coming from negative infinity through -6 to -5 to -4 in set builder notation. What you need to understand is that all these numbers happen to be integers. So in set builder notation, I use my braces, and I want to say the set of all values of X such that X is an element of the integers and X is less than or equal to -4. And that's exactly what this all in symbolic notation says in terms of that number set up there. And don't get so caught up in it, not that big of a deal. You'll see some multiple choice questions on it. We then get into something that is, let's go over here, interval notation, and that uses 2 numbers enclosed by brackets or in parentheses. It could be one of each, it could be both. So brackets, which are those things, and then in parentheses, and you know what those are already. Okay, so you could have different types of interval notations. If you've got 2 brackets, you've got something that's called a closed interval. And these closed intervals work very much as they would open circles. So for example, if you've got this closed interval between 3 and 7, what it's saying to you is that if I were on a number line and here was 3 and here was 7, I would have an open circle on 3, a closed interval, and I'd have a, closed circle on 3, closed interval, and a closed circle on 7, and any number in between that would make sense. Another way to look at this notation would be, well, X could be greater than or equal to 3, and X could be greater, let me get this eraser, and X would have to be less than or equal to 7. Less than or equal to 7. That's your closed notation. If you've got 2 parentheses, you're considered to be an open interval. And that should make sense. Again, if we were on a number line and we've got 3 here and 7 here, I would have an open circle on 3, an open circle on 7, and any number in between. Which means an answer could be that X was greater than 3 or X was less than 7. So if it's got a closed, it means you can include those numbers. If you're open, it means you cannot include those numbers. You might have a case where you've got one parenthesis and one bracket. They call this to be half open. And for this first example, all that is saying to you is, okay, well, I've got a parentheses around my 3, so x must be greater than 3. And at the same time, I've got a bracket on my 7, which means x must be less than or equal to 7. And then what this means would be, if I had a number line, and then I had a 3 here, and I'd have a 7 here, I would have an open circle on 3, a closed circle on 7, and anything in the middle. Last one is this guy where it says, all right, now I've got my bracket on 3 and my parenthesis on 7. This would mean that x had to be more than or equal to 3, and x had to be less than 7. And now if I go to 3 and 7, I flip-flop those. My bracket means I have a closed circle. My parenthesis means it's open, and it's everything in the middle. Just one thing I want to clarify. I need to actually change a word up here. When we've got this open interval, get rid of the word or. It actually means that I've got to be greater than 3 and at the same time less than 7. Sorry about that. Okay. Again, these really come up on multiple choice questions, and on the homework you'll see, and I think you'll find it to be not that difficult. Then we actually have infinity. So that's used when there's only one endpoint. So in terms of infinity, it's a kind of figure 8 upside down. And what that's saying to you is, if I just had infinity on one side, which would be positive infinity, I've got a closed, I guess, system here because I've got this bracket. This would mean x has to be anything greater than or equal to -6. And then I wouldn't have any ending point. I would start at -6. And I'd have, obviously, -7, -5. But then what I would do is I'd have a closed circle. Anything that was exactly -6 or all the way to the right, all the way up to infinity, would be acceptable for that particular type of system. Similarly, if I had the infinity on the left, and now I'm actually having it with 2 parentheses. Infinity will always have parentheses. But in this case, I've got now, I'm starting from 2 being my biggest number, which means x. It's got a parenthesis, so it's less than 2. It goes all the way down to infinity, negative infinity. Let me be more clear. So I've got 1, 2, 3. And now what happens, it's an open circle on 2. I can't include it. And it's going all the way down to infinity. Okay, so those are the deals with your systems. When you have interval notation with open circles and closed circles, and then you've got infinity. We wrap this up with unions and intersections of sets. And the union of sets A and B, think about union as like the marriage. You know, people get married and they bring all their stuff together. It's the union of their marriage. So the union is symbolized by this U. That, oopsie, that should also make sense too, union being like a U. So the union of sets A and B, symbolized by A union B, consists of all the elements that are in set A, in set B, or in both sets. So again, think of the word union as like a marriage. And when you get married, you bring everything between the two of you guys together. The intersection of sets A and B, so it's an upside down U. So the intersection is going to be this symbol, okay? And that consists of all the elements that are common to both sets. So anything that's common is considered to be your intersection. If two sets have no elements of common, then they are considered to be disjoint. So if there's no elements in common, they are disjoint, and it's like the empty set is your symbol. So here's some examples here. You've got set A. You've got these numbers, 1, 2, 3, 4, 5, and 6. Set B has the numbers 2, 4, 6, and 8. Find the union of those two sets. Well, the union is any number that's in either set. I will go just in order from the way the sets are written. So union of set A and B. Set A has 1, 2, 3, and 5. Set B has a 2, but we've already used it, so I'm not going to write it again. Set B also has a 4. We didn't use that number, a 6, and an 8. So the union is any number that is in both sets, and we don't need to write them twice. The intersection then is going to be whatever's common to both. And in terms of intersection, well, what's common in both sets? Well, let's see here. If I take a look at both sets, well, there's a 1 in set A but not in set B. Doesn't work. There's a 2 in set A and set B. That's part of the intersection. There's a 3 in A, not in B. There's a 5 in A, not in B. There's a 6 in A and in B. So 6 is going to be part of the intersection, and 8 is only in set B. So then intersection is just what's in common, and then the union is everything. Sometimes they might actually give you intersection and union in terms of a Venn diagram. Not a big deal here either. You need to look to see what the union is, and the union is all numbers. So what's going to happen here for the union, in set A, I'm going to actually bring that down here. So set A union set B is going to be -8, -7, -6, -5, -3, 0, 4, -2, 1, 2, 3, 5, and 7. All of those numbers. So whatever's in either set. Okay? When it comes down to intersection, A intersect B, that's only what's in common, that's the overlap, and I only have to worry about writing 3 numbers this time, much better, and there you go. Okay, so just be clear that union is any number that's in either set, and intersection is any number that's that's in both sets. Okay, so that should do it for you. When you see your homework, I think you're going to find that it's going to be a little bit more straightforward what they're looking for in terms of union, intersection, or intervals. All right, so good luck with the homework, and I'll see you tomorrow. Bye.